Welcome back, guys, to my channel. It's been a long time, but yeah, I'm back. And I just want to go back to the beginning of partial differential equations, and then I'm going to make sure that I get back on track and make everything, look a bit more. I just want things to be a bit more, chronological, like follow. I want to follow a pattern, okay? Yeah, so yeah, we already know what a partial differential equation is. You have a quantity u, which depends on some space variables x, y, z, w, whatever you can call it, and then a variable t, which is the time variable. And what we have here is that there's a quantity which has all these independent variables, and you can find the derivative of u with respect to each one of them, which we are going to denote in this as del y del x, not dy dx, because it's supposed to be u, sorry, del u del x, not du dx, because u is a function of x, y, z, a lot of variables. Okay, so the first thing you have to know is that this physical quantity depends on more than one variable, and then the derivative of that can be written as that. You can also call it ux. Okay, you can also have u del u del t. That is going to be ut. Okay, so these are some of the notations you're going to see in the lessons you're going to have under partial differential equations. And then you can also have, second derivatives of this u. Okay, so here, how do we represent second derivatives? Since u is a function of not just one variable, the second derivatives are going to be the form. For instance, if I want to find the second derivative of u with respect to x, I'm going to have del u, del del x of del u del x. Okay, and what's that? That's going to be del squared u del x squared, and that can simply be written as uxx. And similarly, if I want del x, no, sorry, yeah, then del u del t, then that's going to be del squared u del x del t. Okay, so that's going to be u t x. Now you have to know the arrangement. This shows that we differentiated t first, and then afterwards we had to differentiate with respect to x. Okay, so that's why I have utx, not uxt. Okay, so one thing too I would like us to know is that these are the second derivatives. No, sorry, these are the second derivatives. Okay, and these are the first derivatives, just in that order. Okay, and what a partial differential equation is a partial differential equation can be written as function of the space variables and the derivatives of the physical quantity with respect to these space variables, or let me not call them space variables. Let's make everything general. Okay, so we have some variables, and then we want the derivatives of these with respect to these variables. We can have second derivatives, you can have third derivatives, and all those stuff. They don't really matter. This being equal to 0. So any equation which has, some set of variables with respect, some physical quantity with, the physical quantity having its derivatives in the equation, then partial derivatives in the equation, then you have a partial differential equation. So example is going to be something like ux plus ut is equal to 0, which we are going to see a lot. We call this the transport equation, and it usually has a speed of 1. We are going to see that a lot. So that is what a partial differential equation is. Okay, and then now we can talk of the order of a partial differential equation. So the order actually constitutes the highest derivative you have in the equation. Okay, so if I have f of x, y, z. Okay, then ux, uy, uz, uxy, uxz, just in that order. And then the highest derivative I can have is just still the second derivative equals 0. Then I have a second order partial differential equation. If it's going to be a third order differential equation, then I should have a u, maybe z, x, y somewhere. I should just have 3 derivatives in the equation, and that is going to qualify that equation as a third order partial differential equation. Okay, so example, when I have something like ux plus ut equals 0, there's going to be a first order PDE. Okay, PDE is uxx plus ut equals 0. What do you think is going to be? It's going to be a second order PDE. Okay, even though you have ut, the highest derivative is just the uxx. Okay, or the quantity with the highest, or the highest derivative of the quantity was 2, so that becomes the order. Okay, so that should be very okay for the order of a PDE. So I think these, oh, okay, so now let's talk about this one too as well. One thing I want us to know is that we assume that these, in this lesson, okay, mixed derivatives are going to always be equal. So uxy is going to be equal to uyx. Okay, uxxy is going to be the same as, it doesn't matter how you arrange the derivatives, they are always going to be the same. So you have to know this one too. Okay, yeah. So one last thing before I end the first video is, what is the solution of a PDE? So solution of a PDE. So u is a solution. Okay, so u is a solution of a partial differential equation if it satisfies the equation. Okay, so what does it mean? So for instance, if u is a solution to this second order differential equation, then it means that if I substitute u into this equation here, I should get a 0 on the left hand side too as well. It should satisfy it. Okay, yeah, so that's just the solution of a PDE. So that's just going to be an introduction, a brief introduction to partial differential equations, and we are going to continue with linearity, homogeneity of partial differential equations, and from there we're going to get more and more deep into partial differential equations. If you like the content of my video, leave a thumbs up and subscribe to my channel, and see you in the next video.